Okay, so we've been doing some mixture problems dealing with money, and in the problems that we did in the video beforehand, we were always given some information that related the two types of coins or dollars to each other. But that doesn't happen all the time. And so this is another trick that you will find very, very helpful. And so let's talk about if you only know the total amount. So let's say I have a pile of 7 socks. Some are red and some are blue. And so you can think about this in two ways. One, if you let the red be x and the blue be y, x plus y equals 7. And, subtract 1. It doesn't really matter which one. And so you get x equals 7 minus y. Or you kind of do this in your head anyway. If I have red over here and blue, I say, okay, if there are, say, 2 red socks, how many blue socks are there? I hope you answered 5. And how did you get that? Well, you took 7 minus 2. And so if I say, okay, there are 6 red socks, how many blue socks are there? 1. How did you get that? You did 7 minus 1. And so if I don't know how many red socks there are, we're going to do the same calculation. Oops, that should be 6. But instead of plugging in an actual number here, we're just going to plug in that x. And so the expression that represents how many blue socks there are would be 7 minus x. And this works anytime you have a combination of two different things. So maybe you have a combination of pennies and nickels, and you know that there are 7 coins in your hand. Then you can use this same trick in order to be able to represent how many coins you have. So let's do an example of this. For the 7:30 showtime, 140 movie tickets were sold. Receipts from the $13 adult tickets and the $10 senior tickets totaled $1,664. How many adult tickets and how many senior tickets were sold? So, okay, we read the problem completely. The next step I encourage you to do is say what we're trying to find. We're trying to find adult tickets, which I'm going to call A, and we're going to try senior tickets, which I'm going to call S, hopefully. And so because this is a mixture problem, let's go ahead and do the chart that we've been doing. So I'm going to go ahead and just say A and S here. So we're going to put the value and the number and the total. So what is the value of the adult ticket? The value of the adult ticket is $13. And what's the value of the senior ticket? The senior ticket is worth $10. And so now let's talk about the number. And so again, this time they don't give us a direct relationship between them, but I know the total number of tickets right here. And so we can use the trick that we talked about before. We say, okay, I know that if, say, A adult tickets were sold, then if it were to add up to 140, then I'm going to subtract whatever that A amount is from 140 to get the remaining tickets that had to be senior tickets. You also could have done that by saying A plus S is 140, and then subtracting the A in each case. And then you would have gotten S is 140 minus A. Whatever you need to do, but that's kind of the trick behind this. And so then we were saying value times number gives us our total. So this becomes a 13A, and value times number, so this becomes a 10. Remember to put this one in parentheses because you have more than one term. And then when we add these together, they have to equal, I covered it here, they have to equal the 166.4. So let's do that. 13A plus 10 times the parenthesis, 140 minus A has to equal 1,664. Let's go ahead and solve this. Distribute first, which adds another 0 there, makes that a 10A. Combine like terms, makes that 3A. Subtract the 1,400. So now I have a 3A is equals 264. Last step is to divide by 3. So now I've got A is, go to my handy dandy calculator, 263 divided by 3 tells me it's 88. And what does A represent? Senior ticket, or no, A represents adult tickets. So that's one answer, but we also need to figure out the senior tickets. We said that our senior was 140 minus 88. And so calculator, because yeah, that tells me that there's 52 senior tickets. So that's a pretty handy little trick. I've got one more example for you. And this one is slightly different. We're going to follow the same procedure, but I'll show you where it comes up different. Macario is making 12 pounds of nut mixture with macadamia nuts and almonds. Macadamia nuts cost $9 per pound, and almonds cost $5.25 per pound. How many pounds of macadamia nuts and how many pounds of almonds should Macario use for the mixture to cost $6.50 per pound to make? Okay, so what are we trying to find? We're trying to find macadamia nuts. Let's call that. And we're trying to find almonds. Let's call that A. Okay, let's go ahead and make our chart. So M, A, we're going to put value, we're going to put number, and we're going to put total. So what's the value of the macadamia nuts? The macadamia nuts cost $9 per pound. And what's the value of the almonds? The almonds are $5.25. The number, are we given a relationship between the two? I don't see a relationship, but I know he wants to make 12 pounds total. And so, where did that come from? And so we're going to use our trick. You can either say that M plus A is 12 pounds. And so, let's subtract out the A. And so our M is 12 minus A. Or you can say, oh, I'm going to let A be, and if it has to equal 12 pounds, then the M has to be whatever the remainder is. Either one. Does it matter which one you solve for? Absolutely not. You could let the number here be M, and then have this be 12 minus M. You'll get the same answers at the end. Just the numbers will be slightly different along the way. So, okay, we said to get the total, we're going to multiply the value times the number. So 9 times, there's more than one thing there, so put it in parentheses. And then 525. Oh, I should have gone the other way, then I wouldn't have had to deal with decimals. Oh well. as much. No, whatever. Okay, so we're going to add these together. And when we add these together, here's the one part that's different. Normally when we add these together, we get a dollar amount, right? A dollar, just a flat out dollar amount. But here we want the total to be $6.50 per pound. Pound. What does this word per mean? Per means multiply, so I still have to take that $6.50 times something. Well, we're talking about a total here, right? And so we're looking at this per pound is times the total pounds. And so what's the total number of pounds is back up to this 12. And so this $6.50 per pound is really going to be a $6.50 times the 12 pound total. Right? Okay. Well, let's put all that together. So now I've got my equation is going to be 9 times 12 minus A plus 525 times A is 650 times 12. Okay, distribute this in. 9 times 12 is 108. Minus 9A plus 525A, and 650 times 12 is 78. Combine like terms. Negative 9 plus 5.25 tells me that this should be 108 minus 375A. Subtract the 108. So we've got a negative 3.75. A equals a negative, is that 30? Divide by the negative 3.75. Oops, try that again. Negative 3.75. Go to our handy dandy calculator. We get A is 8. Well, what does that 8 represent? Is that a dollar amount? No, A well, it represents almonds, but it's the number of almonds, right? So this is pounds of almonds. And then we still need to figure out M. Well, we said M was 12 minus A, or in our case, 12 minus 8, which makes it 4. And so that's 4 pounds of macadamia nuts. And that's going to be our answer. Okay, so hopefully you got some tricks in order to be able to do this. As I said in the first video, there are tons of videos on this. If you go do a YouTube search for mixture problems, you'll get lots and lots of videos. Also, the book does a really good job of explaining this and kind of stepping you through it. So I encourage you to go check those out too. As always, though, if you have more questions, please let me know.